Welcome, everybody. If you can, or maybe just indicate that you can hear us fine by typing in the chat on the left-hand side of your screen. Just say a quick hello. We are very excited to host you again. We've got a wonderful presentation coming forward. Thanks again to Hilary. He's going to be walking us through a deeper dive into soil biology. So let me just start off with some introductions. Thank you, Frank. If you can just give a little thumbs up or a hello in the chat box, then I know that everything's good and we can continue. In the meanwhile, I can say, there you go. Thank you, guys. Thanks. How's it, Noel, Andres, Sean? Thank you, Connor. Nice, lovely to hear from you. Okay, we've got Hilary Murphy here from Soil Biology. He is an expert in the field when it comes to soil biology and turf management, years and years and years of experience as an agronomist. So he's got a wonderful, informative presentation to walk us through soil biology and soil defense. So we've also got Carlos here, who is the co-founder with myself of Macroorganics Europe, and he covers the Southern Territories, and I'm doing the Northern. So he'll be managing. You can say hello, Carlos, if you want to say.
Hi, everybody.
He'll be managing the chat. Please, if you've got at any point, you just want to make note of a question as Hilary goes through. There will be a Q&A at the end, but please feel free to just make a type of question in the chat box. If it's appropriate, I might interrupt Hilary. Otherwise, we'll just leave the questions till the end. It's probably best we do it like that. But please type in the chat box, because then we remember the questions that are that are appropriate and that are meaningful to you. In the interim, I've got Paul Bars, who is the groundsman for the Jan Cruyff Amsterdam football field. He is not available to give a short discussion, but he has given us a wonderful little video that I'm going to play. So this is just a little warm-up as I see people are still entering the registration. So I'm going to play a short 1-minute video just to mention a little bit about what OxyTurf has done for the Amsterdam Stadium, which obviously the Ajax Football Club is using all the time. One of the biggest challenges greenkeepers and groundsmen face across the world is anaerobic conditions in the soil profile. Hi, I'm Luke. I'm from Macroorganics International, and what we're bringing is a new patented product called OxyTurf. And OxyTurf, it brings aerobic bacteria to the soil profile and slow releasing oxygen. We're getting amazing results, really improving their turf condition and their turf management program. I'm going to introduce Paul Bars to you right now, who's the lead groundsman, and he'll give you a few words on what OxyTurf has done for him.
Yeah, it's for me. I use it now for a year, and it's quite. I see good results. We have a very hard stadium here with high moisture level. The soil always stays wet in the top layer, so we use the products to get it more dry in the top layer, and also the disease pressure is going down. It fits completely in our green idea about using products for the grass. So yeah, I'm happy with it, and I see some good results, and the pitch is getting better. The grass governance is good. So yeah, for me it's a good application for my grass maintenance.
Super. So that's from Paul, just giving a lovely reference regarding what OxyTurf has done for us. And I think that's enough from me. I'm going to pass straight on to Hillary. Hillary, you are on mute at the moment. I'm just gonna can I unmute you? There you go. You can take it away.
Good afternoon, gentlemen. Thank you very much, Luke, Carlos, for inviting me back again. As all of those in the biological world know, we're actually on a bit of a journey together. It's not an absolute science, but let's have a look where it all started. And what I want to do today is to use various slides and images to help you remember stuff. Because a wise man once said that nothing is taught until it is learnt. So there will be a little bit of repetition today, and I make no apology for that, because I think in the time that you've allocated to watch this afternoon, I think it's very important that you take away as much knowledge as possible with the first contact, and then if you're motivated, I'm sure you'll have a chance to listen to the replay. So what have we got in front of you? What we've got in front of you is a natural woodland. We've got absolute nature doing its thing. We've got photosynthesis occurring up here. We've got CO2 being taken out of the atmosphere. We've got the energy from the sun. And we all know the function of light and chlorophyll. But most importantly, what we've got to look at is what this form of biology contributes to the slide that you're busy looking at. And what we're going to focus on today is this pathway here and this pathway here, and then to a lesser degree this pathway, but to a greater degree in the next seminar in 4 weeks' time, probably, we'll be focusing a lot on that. But we will touch on it today just to raise awareness and to give you some encouragement to tune into the next seminar. So what we're going to do now is we're going to say this is what nature presented, and what we're going to be doing this afternoon is trying to recreate all of this in your playing surfaces. So in all your amenity grass situations, we are going to be trying to replicate this through the introduction of biostimulants. And so what we're going to do now is just move on and actually talk about what biostimulants represent and why they're important. We all know that your gut is lined with microbes, but unfortunately the gut of a plant is not big enough to support that. So the stomach of the plant, as we all know, is in the soil. And what is very important to understand is that soil microorganisms always feed first. And that is even with chemical fertilizers. If you think about the nitrification cycle, the microbes have to do the job of conversion, just as they do in the stomach of a human or an animal, or a mammal, I should say. Right, so let's just focus on where all this action is taking place. Most of this action is taking place in the rhizosphere, which is an area about 5 millimeters either side of the root system. And you'll see a stat here telling us that up to 21% of all photosynthetically fixed carbon is transferred from the plants to the rhizosphere through root exudates. You're going to learn another word a little bit later, which incorporates exudates as well, and we'll touch on that when we get to it. So what we have is what I described earlier, is we have photosynthesis taking place in the leaves of the plant. water being provided by the xylem and carried upwards from the roots into the plant, and the phloem transporting that energy down into the roots of the plant. And this is,
Hilary,
yes.
just so that you're aware, we don't see your mouse as a pointer. So when you are describing things, try and describe it in a manner in which we can understand, because we can't see your mouse.
Oh, I'm so sorry.
No
Okay,
problem.
okay.
Super.
I'll bear that in mind. Okay, so hence our relationship with OxyTurf. It was a natural addition to our range, especially in the fact that OxyTurf can both kickstart the biological operation and support it. I've got a case in question at the moment where I wanted to use gypsum to improve percolation in a football pitches, but because the calcium levels were so high, I couldn't resort to my normal practice of using gypsum. But thank goodness we've got OxyTurf to rely upon to do that for us. Moving on then, we get to understand that OxyTurf can be used to increase and build a greater biological activity. And with all of that happening, we are supporting the soil food web. Now, the soil food web has been a buzzword for over 30 years. And obviously we have to thank Elaine Ingham for this, for her commitment to drawing attention to the function that microbes play in nutrition and defense mechanisms of plants. But what this means is that we are not just relying on primary plant feed anymore. We are taking advantage of the relationship between microbes and plants, and especially the exudates. And as I said, you will hear that word quite often today, but there is a similar description coming a little bit further. And just to, if you look right at the back, right at the bottom, where I talk about the conversion of ammonium, NH4, a very weak cation with a single positive charge. When we talk about the conversion of ammonium into nitrite and then into nitrates, the favorable form that a plant will take up nutrition, we know that microbes are heavily involved in that operation. So no matter what your soil type is, there's always a role for microbes to play. Now let's just define where these biostimulants work and how they work, and why it's so important not to neglect chemistry and the physical operations that greenkeepers and groundsmen are involved in, because the biology can't do it all on its own. But we know that biostimulants feed bacteria and fungi and a lot of other microorganisms. And as we did last time, we'll now start referring to microorganisms as critters, because they are critically important to us. On the physical side, obviously groundsmen and greenkeepers are well equipped, but microbes are also making an incredible contribution to the physical changing of the soil. And then, as we learned at our last webinar, the chemical changes are just as important. So when we have this balance of biology, physical and chemistry working together, we know that we've got the full Monty when it comes to microbes and biostimulants supporting the soil food web and supporting nutrition. As we move on now, as I said, there are going to be certain graphics that are going to remain in your mind, as a way to boost your memory banks. And I would like this to be just one of those type of slides that you picture. As we described earlier, the rhizosphere represents 5 millimeters either side of the root hairs and the roots. And right in the middle of the root, we have a bundle, a vascular bundle called the xylem and the phloem. And as mentioned, the xylem is very important for the translocation of waters and salts up the plant. And the phloem is very important for the movement of carbohydrates and sugars to the lower regions of the plant, and especially to the roots. And there's the mystery name that I have for you, the mucolidge. Now, mucolidge is described as a thick, gluey substance produced by roots. Now, that mucolidge also helps to bind soil particles. So you can see the root is playing a massive role in the whole soil food web and the whole feeding and the whole support to the plant. The other thing to note here is that there is an epidermis, which is the outside protection of the root, and there's an internal protection called the endodermis, which is protecting the xylem phloem vascular bundle from the rest of the activities that the roots are involved in. So there's a new name for you to remember, plant mucolidge. And right at the base, you can see cap cells coming off the root, and that is predominantly calcium. And if you manage to get good calcium uptake, this is where this exchange happens, right at the root cap of the root. So as I said, keep this one in your memory banks. We might even come back to it if we have time. Right, now we're going to look at what biostimulants target. In other words, what organisms are they targeting predominantly and why? In our presentation, you'll see later on, we'll talk about bacteria to fungi ratios and how important these are. But what we have to emphasize right here now is that when we are working with fungi, we are working with populations that are much lower than bacteria, but fortunately, they are larger and heavier. So when you work out these ratios, it's all about their weight. And this helps us to get these bacteria fungi ratios, which we will deal a little bit with further on. Fungi, for us, is probably the most important. And fungi are responsible for a lot of processes in the soil food web, which helps us break down thatch, plant organic matter, but we will touch on that as well. Now, what I've identified here, and I won't go through all of them, is the fungi and the food source which best promotes them, and what we get out of the various what we get out of the various biostimulants. Our second target, the second most important target, is bacteria. Now, this we will deal with quite extensively in our final webinar in a month's time, because we see now that bacteria are being used quite extensively for plant disease control. And there are a number of certified biological fungicides coming onto the market, which bodes very well for the future of microorganisms and their function. The third most important target is the defense mechanism. At this point in time, what you see on the screen represents the products that we have available. And this is all about getting the plant to improve its own systemic resistance. So a lot of the products you're seeing now actually improve they induce systemic resistance. And a lot of the products that we've looked at back here, actually improve the systemic acquired resistance. So this is keeping a plant healthy to an extent that it can fight off disease on its own. So looking at these products, we'll see that they have been fine-tuned to induce resistance and are designed for that particular purpose. Moving on, and as I said in the beginning, this is really a journey through biology and everything that biology can bring to the soil food web. The fourth target, and I believe this is just as important. I work with a number of schools and sports grounds that do not have irrigation. They're reliant on rainfall, and in that situation, we are committed to improving soil structure. And we know the role of nematodes, especially beneficial nematodes. We know how they can create the pore spaces for water to percolate. And we know how important thatch degradation is in allowing water to move through these soils. And also we're finding now, as more studies are done, that even bacteria are just as important in creating that gel that we spoke about earlier, that gel which helps to bind your soil colloids. And then, as we know, if a soil is full of pollutants, and if you remember our last seminar, we emphasized the breaking down of salts, and we are very privileged in that both beneficial bacteria and biology and soil biostimulants do all of this for us. Soil fungi, how do they enhance soil quality? Now this is a great subject. This is a great topic, and we could spend a lot of time on this. And if time allows, I've just got my eye on the clock. If time allows, we could even come back to this slide. But the importance of fungi I've introduced earlier. But if we look in depth, we can see that fungi are a means of competing against plant pathogens. And yes, we know that a lot of development is taking place in this field, and you will soon be seeing registered products along that line. Soil protozoa. These are one of my favorite little critters. In fact, they're not so small in terms of microorganisms. They have quite a large body size, and they're amazing in the fact that there are 3 different types of protozoa, and these guys do a lot of work in carrying ammonium in their bodies, NH4, and they go around devouring bacteria, and whatever they eat, they excrete, and they're releasing NH4 into the soil, which then goes through the nitrification cycle, and your plants end up with beautiful free nitrates, which they can easily take up and utilize. So When we look at Protozoa, we know that they're releasing nutrients as well as holding nutrients. So they play a great role in the recycling process, the recycling of nitrogen and other nutrients. And like everything in nature, we're all made up of a ratio of carbon and nitrogen. And some of these critters do not need as much of the nitrogen that they consume. So they end up passing out more than what they consume, because generally they're after the carbon, like all soil and plant life. Carbon is just so vital to the ongoing food web cycle. Soil nematodes, we touched on a little bit earlier, but as I said, there will be a little bit of repetition so that we can walk away from this seminar having really been taught. Soil nematodes are getting a lot of publicity lately, especially those that are designed to feed on larvae and of leather jackets and chafer grubs, but they're used in a lot of other situations, in strawberry production as well. But what we're talking about here are the natural predatory nematodes. And these are nematodes that one can introduce through various methods, including compost teas and such like. And the beauty of nematodes is that they support the whole soil food web so adequately. So just to reinforce, biostimulants ideally suited in combination mixes. And what we mean by this is that you can mix various biostimulants to do an overall reinforcing of fungi, bacteria, protozoa, and nematodes. And we also have, as you're probably well aware, we have biostimulants that actually control nematodes, that control the nematodes that are root feeders, and we can control them biologically through a selective process of using biostimulants. And as we know, the product Cartazan fits into that bracket beautifully. Right, getting back to OxyTurf, getting back to its role in supporting the soil food web, all the products that we've looked at, all the microbes that we looked at, the critters that we looked at, all benefit from OxyTurf. And whether it's a bacterial stimulation or biological stimulation, we're getting the same result. Now, without contradicting myself, where we are seeing this, come winter, we can use OxyTurf to stimulate bacteria. And through that, we can get great thatch degradation, not as active as we would in the summer with fungi, but we can keep the thatch and the plant organic matter under control. And we're also finding that the OxyTurf is promoting the bacteria that are designed, and these guys are known as the PGPRs, the plant growth promoting rhizobacteria. So in winter, the bacteria are really enjoying OxyTurf in improving their activity and improving their activity and improving their development. In other words, helping the bacteria to survive the winters. Right, additional biostimulants. This will soon be available to us. And of course, we all know the value of seaweeds in their multiple function purpose. They really help with various functions and make a valuable contribution to the soil food web. And what I like about seaweeds personally is that one can use them all year round. And then they play a special role in the winter months in relieving plant stress and taking up nutrient through their stomata as a foliar feed. Now, here is the key to what we've been discussing. We want the microorganisms, the critters, working for us. We want to reduce fertilizer and chemical inputs. We want to get away from expensive failures. And we're finding now that through science, sorry, let me get rid of this. Yeah. We're finding that through science and the development in science, and as these biological fungicides are encouraged and researched, that if we've got the environment that is ideal for them to work in, we know that biostimulants will be able to be combined with these biological fungicides, and it would be seen and used as part of your fertilizer program as well. So what we're trying to do is to get root zones cleaned up either through the OxyTurf or through the seaweed or through the humics and fulvics, which we'll touch on a little bit later. But so we are preparing ourselves for what is to come in the future. If we were reliant on nematodes, for example, we want to make sure that the soil profile is not going to be disadvantageous to their growth and development. If we're going to use biological fungicides, we want to make sure that we're going to get the best out of them. So biostimulants in this context can be used to restore your profile and get it all nice and healthy again. What are we achieving working with soil organisms? Healthy plant growth, reduced nutrient requirement, reduced fungal activity, dry patch, fairy rings, reduced water requirement, reduced labor requirement. I've worked with a school in the middle of London. When I started working with them, they were using irrigation throughout the whole summer. After 2 years of introducing biology across the board, introducing fungi, bacteria, protozoa, and nematodes, after 2 years, this groundsman actually turned off his irrigation because he found that the roots were now extending and less water was required. He found that there was greater friability in the soil and the roots were going down deeper and were able to call upon those reserves of water that were adequately supplied during the wetter periods. And yes, we know the word sustainability is quite a buzz, but yes, we all know that we have to be more sustainable. We all know that we are losing the traditional fungicides and chemicals, and we have to look at alternative ways of managing our jobs. And this is where we believe we can play such an important role. If you think about it, your soil profile is a battleground, because in that battleground, we have got so many little functions carrying on. I spoke about earlier how the protozoa go around eating up the bacteria, but that process is going on all the time. And what we are actually doing is we are harnessing the energy. We are harnessing the energy that the microbes are releasing. We're harnessing that energy to work for us, to get the soil profiles sorted. And as I mentioned earlier, the new buzzword now is plant growth promoting rhizobacteria. These critters are doing such wonders for us. And although we cannot make claims about what they're doing, we all know and see. Exactly what they're doing. Here we have a picture, obviously under a microscope. I think this would be at about 400x, and here we can see the actual bacteria on the tip of a feeder root. And I mean, you can see they gathered there. They are playing their role in giving back to the plant what they busy receiving from the plant. And we'll cover that a little bit later with the importance of exudates. But these bacteria are actually feeding on exudates, carbohydrates, and sugars, which are produced by the plant. And as a little plug for my company, largely generated by foliar feeds. And we know that it's recorded that a perennial plant can exudate up to 40% of the nutrition that it takes up through foliar feeding and put it back into the soil food web, put it back into the soil. Soils can be bacterial or fungal dominant. Okay, this is what I alluded to earlier. And what does this all mean? And why do we want a fungal dominant soil? A fungal dominant soil promotes the finer grasses. So our fescues and bents, in fescue, bents and rye in the UK, in other parts of the world, you have other grass species, but in general, all life that produces a lignin benefits from fungal dominance. Now, what does this fungal dominance mean? As I mentioned earlier, it's all about the weight of the fungi and the weight of the bacteria. There are always going to be millions more bacteria than fungi, but when you put the combined weight of the gram-positive fungi together and the combined weight of the gram-positive bacteria, that is what we're referring to, when that ratio is a 1-to-1 ratio. And here we have what we call the trophics, and we look at Poa annua, and the ratio of fungi to bacteria. You'll see the fungi ratio is extremely low, and Poa, being an invasive species, is designed to take over any bare ground, and that's its function. So it can operate where you have bacterial dominance. As you move further up, and you now start getting an annual perennial Poa, which some Gulf greens unfortunately have, you'll see that in this situation, you get an increase in fungi. Still not equal ratio. When you get to your mid grasses, your rye and your fescues, you can see that the the fungi are increasing, but still not at that 1-to-1 ratio that we desire. And then we come to the fescues bents, and here's where the fungal dominance really benefits you in terms of slowing the POA's ingression down. In other words, the POA is not overly encouraged to live healthily in that environment. It will not kill it, but this 1-to-1 ratio promotes the finer grasses. Okay, what effects do we have from fungal dominance? Aha, and this is where the real benefits are gained. Through exudates, we produce acidic carbohydrates and sugars, and your fungi feed on this. Your fungi prefer a acidic environment, and so all the while we are promoting the fungi, and while we're promoting the fungi, we're breaking down all the lignin that these typical grasses produce. We know that fescue produces lots of lignin, and what we're trying to do is convert that lignin into organic plant material, into organic soil material. Sorry, we want to turn that into soil organics. And with the release of these organic acids, you're literally, as you break down plant organic matter, as you break down thatch, you are producing a secondary product very similar in nutritional status to seaweed. And with that lowering of the pH, you are then making so much more nutrient available to the plant. And of course, we'll touch on this further, the greatest fungi that we have on earth, and that's mycorrhizae. So we'll touch on that a little bit further, but all of these are helping to contribute to the survival and the proliferation of these microbes, these valuable critters. This is what a protozoa looks like. He actually looks like a bus in terms of the critters, and he's the great recycler of nutrient. He will hold NH4 in his body as he gobbles up bacteria. And while he's moving, he's burrowing through the soil, creating those spore spaces, and encouraging aeration and encouraging water to move along those pathways as well. And in short, all of the microbes are doing that for you, just some doing it a little bit more actively than others. I have a customer who, this is his first year at compost teas. The golf course is about 38 years of age, and he has rebrewed all his compost teas. So the main brew has gone on to the greens, and all the rebrews have gone on to the approaches. And this year he has put no fertilizer at all on the approaches. And I put it down to these critters. They are so helpful, they are so useful, and the action and the work of the protozoa has replaced fertilizer. Here we have amoeba, which belongs to the same family as the protozoa, so also a little bit larger, a little bit slower in movement, not too readily found, but wherever you have water, you will find amoeba, and like the rest of the critter family, they're great at aerating and recycling nutrients. Here we have a bacteria feeding nematode. So this is a nematode. You can see his mouth parts at the bottom end. This is a nematode that will actually feed off bacteria, but don't panic. There are billions more bacteria than he can cope with. But by feeding off bacteria, he's releasing NH4 ammonium back into the soil profile, and that ammonium is converted back into nutrition as well. Here we have a fungal feeding nematode. You can actually see how he swallowed a fungus. If you look at the top end, the raised point, that's his mouth. He's swallowed a nematode, and so you've got the good nematodes, and of course you've got the bad nematodes. And what's most important is to keep the balance of all of them. When the balance is upset by not having the right balance of the rest of the critters, that's when you get the nematode imbalance. And if you are faced with any stressful situation, an area that doesn't get watered during a very hot summer, that's where you'll see nematodes where nematodes will show and prove quite destructive and can actually be a major problem. So, as I said, if we keep the balance with the rest of the biology and regular application of biostimulants, we can prevent that. Moving on, we've got a predatory nematode, and yes, this might be quite a lesson in nematodes, but I want to make sure that people understand today that nematodes are not all bad. And if the balance is kept in control, they can do a great job for you. Here we have the root feeding nematode, very distinctive. This is the one which I tend to look for in greenkeepers' offices, those that carry microscopes. We just put a little bit of dye on the microscope and you can pick up the stylet. And this is the one which we can control with the cardizan, because they do not like the taste of cardizan. So if the cardizan is in the plant, they cannot feed on roots anymore and they weaken. And then this bugger will come along, this critter will come along, this predatory nematode, and he will gobble them up. And that's how we can selectively control the nematodes, by using a biostimulant and understanding exactly how it works for you. And hence the importance of today's webinar, that we understand exactly what job the biostimulants do. And then we come to my real favorite. I still believe that every farmer in the world should be using this stuff, using this fungi. It's a fungi which extends the root area of plants. It can extend the root area by 400 times. It's a great scavenger of water. I've seen trial work done on potatoes in the UK where a 50% reduction in water and nutrition was applied for an equal yield. So for all those battling with lack of irrigation on their fairways or on critical areas on their sports pitches, this is the fungi to remember. And the other tip that I can give you, and this comes from Dr. Alan Gange, always put your mycorrhizae down with your seed. That comes from Dr. Alan Gange, Royal Holloway, through extensive work from a paper that was actually published in SDRI in 1999, that far back. And this is probably one of the most neglected microorganisms in our industry. And I encourage you to research and look into it. There is a wealth of information on it. Moving on then, what happens to energy underground? This is one of the favorite subjects of our Irish representative. Andy just loves this topic, absolutely promotes it. And what we are very fortunate to have learnt through clever studies and scientific papers is that in applying foliar feeds, we do not need very much to stimulate exudates. So whatever we apply to the leaf area moves through the plant and produces sugars and proteins which are sent out through the roots, and these feed the soil microbes. And when that conversion is taking place, when that feeding is taking place, the microbes convert protein to ammonium. Apologies for an earlier slide where it had it down as ammonia. That was a slip. Ammonium is the correct terminology, NH4, and that's what your critters excrete. And that's what your plant excretes as well. So everything applied to the foliar plant, everything applied through the foliar, be it a biostimulant or a part organic foliar feed, ends up in the soil. And that's the beauty of nature in terms of adapting to receiving a foliar feeds. And we're going to come on to Fulvics a little bit later, and we'll see how Fulvics enhance that. But first of all, we'll start with humic acid. If we go back to the slide that I posted up first, it was actually the second slide, but first in terms of the proper presentation, where we saw what a natural woodland looked like, going back thousands of years, and I mentioned that is what we're trying to recreate in the soils and surfaces and greens and rhizospheres that we're working with. And here we have a humic acid, which, if you remember that slide, I said we're going to concentrate on the two sides, and both of those sides produce a humic. And humic acid is very important in terms of building up carbon, and through its interaction with microbes, it improves soil structure by producing those gels we spoke about earlier, which form lovely aggregates of your clay colloids. They improve the absorption of nutrients already present in the soil as well, which is vitally important. And as all biostimulants, they encourage higher microbial activity. Now, just as a bit of a revision for our last presentation, where we spoke at length about cationic exchange, and we learnt about the positive cations that are drawn to the negative cathode, and we learnt about the negative anions that are drawn to the positive anode. But more importantly, what we need to remember today is that cationic exchange is all about holding as well as releasing nutrients. So if you look at our two buckets, you can see that there is a limiting factor in the fact that one of the nutrients is below what it should be, and the liquid is pouring out there. This is an analogy as to what would go on with your plants as well. That if there wasn't enough balance in nutrition, you would get a leak of and that in turn would prevent the plant from performing to its maximum. On the left, you've got your major cations. You can see that they all have positive charges, although some only have a weak single charge, and others like aluminium, calcium, and magnesium are bivalent and have 2 positive charge, which helps the clay colloids hold on to them longer. But as I said earlier, what's more important is to remember that cationic exchange capacity is all about what the soil can release to the plant. And that release is improved and increased through the positive action of soil microbes, through the positive action of our critters. And the critters need energy as well. I said earlier, we're harnessing their energy, we're harnessing the food that they produce, but they need energy in order to be released for the plant to take them up. So the plant is stimulated, the microbes are stimulated, and the cycle continues. Here we come to my favorite, fulvic acid. And what's so important about fulvic acid is that it's a biostimulant, but more importantly, it's a natural organic chelating material. And it has a very, very fine density, which allows it to pass through the cell walls and the stomata of plants. Fulvic acid should always be your go-to biostimulant. From my time back in agriculture in South Africa, and in my time, the last 13 years in the UK and Europe, this is the first product that goes into the spray tank, because this product buffers the water. Using the word buffer is not exactly true, but because most of the water in England and the UK and Ireland is of a very high pH, by reducing the pH, we can say that we are buffering it to an extent that all other products that you add to the spray tank will have their efficacy improved and increased. But it's not a true buffer in the true sense, because a true buffer will go in both pH directions. But because we deal with water that's got so much lime and so heavy with bicarbonates, we can take a bit of license and say that the fulvic acid is actually buffering the tank mix. But on the slide, you'll see all the other valuable contributions it makes, and especially the contribution in improving low light conditions, because with its natural chelation, it's carrying the rest of the products that you have in your spray tank, if they are so designed, into the plant. It's helping you take it into the plant for you. As I said, we will have some repetition, and this is designed so that you make quite sure that you're aware of what's actually in seaweed and why it's so important. The laminarum is a source of carbohydrate compounds for bacterial growth. The mannitol is specifically for improving the uptake of nutrients, and the betaine is efficient in promoting growth. So, as I said earlier, seaweed for me is a product that can be used all year round. A lot of people tend to use it through the winter months, through the colder months, but I would be happy to say that I'd promote it to be used right through the year. Now we come to something extremely important and probably sums up this slide in some respects sums up everything that we're about in terms of soil biology, microorganisms, biostimulants, and everything else that supports our system. We call our programs a system because we're not just taking something from there and something from there. All our products have been specifically designed to assist in the system working better. And carbon is probably one of the most important materials that one needs in the soil to sustain microbial life. And most of the biostimulants that we work with are improving the carbon content in the soil, and carbon plays a great role in improving aeration, improving water infiltration, chelation, increase of phosphates, phosphorus, buffering acidic soils, as we spoke about with the water, because water rich in bicarbonates, soils are rich in carbonates, and sometimes we need to get those pHs down to facilitate the uptake of nutrient. And there we have it right at the top, and that's why it was so important to reconsider this slide, number 30. Reconsider this slide and the role that cations and anions play in holding on to ions that soils play, that cations and anions play in actually enriching the soil and enriching the plant. Never forget that. There's a dual responsibility there. There's a dual action there. So seaweed, I believe we are making progress, but we'll probably keep that for the next announcement. But we are making progress with Atlantic kelp, soon to be gracing our shores. Carbon, as I said, the most important element for the continuation of microbial life and for the enriching of your soils. Without carbon, you cannot have soil enrichment. And then this is one of my favorite slides from my agricultural days. Unfortunately, my arrow is not working, so I'm going to start in the top left corner, and I'm going to go clockwise as you see it. Top left corner in an ag environment, and this is showing you the soil food web operating above and below the soil. And this is a maize plant, and you can see its root structure. But top left corner, we've got the shredders, and these are the guys that come and break down anything that's left on the top of the soil. On the top right, as we go clockwise, we've got the predators. Bottom right, we've got my favorite, the Protozoa. Bottom right, we've got the nematodes. Then we've got center below bacteria and fungi working together. Then we've got the herbivores, and continuing the process, we've got the grazers below soil. And that's just to plant another image in your mind of what is going on below our feet. Just to plant an image that you will retain, and hopefully it will help you remember bits and pieces of what we've discussed today. We're now going to move into a very interesting section, which we're not going to do in depth, because this is just to give you an introduction into our third webinar in a month's time. just to show you how we are progressing and how next year we will be putting out a fully organic soil association approved range of micronutrients. We are selling these at the moment. We're selling some of these at the moment just for normal amenity usage. But what I want to do is just plant the seed in terms of the progress that has been made. These are made in South Africa. These are made in the UK. They come from an American formulation, from an American manufacturer, but they're made in the UK now under license and by a British citizen. And this is just to show you how things are moving forward so quickly that we'll have micronutrients, even iron, that are organically certified, and these will then become part of our improved integrated pest management training. These will play an integral role in that integrated pest management, where, as you know, I spoke earlier about certified organic biological fungicides, and as I spoke earlier about products that are being developed and are already on the market. And so these will play a role in that. And just to show you how well developed they are, I'll just give you a very quick introduction. Chelation, a biological process essential to life on Earth. Here on the left, you've got the molecule showing how it's all done. And on the right, you can see that thousands of years ago, there was natural chelation for material, for plants to grow. And what is so unique about this chelation process is that even if you've got soils that have got a pH range of 3 to 11, they will still work satisfactorily. And that is so important because in a lot of areas that we work in, we find some very high pHs, and in some other areas, especially on links courses, we find some very low pHs. So we have a range of micronutrients that'll work in all those pH spheres. And just to give you an
it appears like you've gone on mute. Hillary? Camera is off.
How's that?
There, your voice has come back. Your camera is gone, but your voice is back. So maybe just check the camera button there. We've got your vocal back now.
Okay. All right.
You're back. Thanks.
Thank you. Sorry about that, guys. I really apologize. All I'm doing is moving the mouse to flip the slides on. So if you look at a map of the UK and you look at the top third of Scotland, we've got nice acidic soils. And as you come lower down into the southeast, you see we've got soils of very high pH. And as we know, high pH soils, we struggle to get nutrient uptake. So as I said earlier, this is just a brief introduction to what to expect in our third seminar, where we'll be taking everything that we've learned from the chemistry presentation and the biostimulant presentation, combine it to give you a proven IPM strategy for the autumn and winter period. Thank you very much for your attendance and for staying on board. And cheers for me now.
Okay, wonderful. Hillary, that was absolutely fascinating and very educational. Thank you so much. You did a great job there. We have a few questions that maybe you can field for us, Hilary.
Yes.
I'm going to start at the beginning. We had, two questions maybe similar. So one, can one reduce the treatment of OxyTurf to 10 liters per hectare, or what is the lowest rate at which it is still effective? And I imagine for two reasons: one, to keep it within the boundaries of a budget, and but two, just in terms of efficacy, what have you found?
Okay, I've been very fortunate to work with OxyTurf since last year, November. And what I have found is where you have a reasonably good, clean root zone, which might take a 30-liter application of OxyTurf, or it might take a 20-liter application of OxyTurf per hectare. Let me emphasize that, 30 to 20 liters of OxyTurf per hectare, especially if we are facing an environment that has been peppered with salts. Now, I'm not going to call out the products that are to blame for the salt increases. That is not my job. But you, as a agronomist, groundsman, or greenkeeper, will know what you've been doing with your soil root zone. So if you had a contaminated soil root zone, I would be looking at 30 liters a hectare down to 20. And once you've cleaned that up, you'll get away with 10 liters per month. In fact, I had a customer who was getting such excessive growth at 20 that he just naturally, without even asking me, dropped it down to 10. And then he found that his clip rates and what he was taking off in the boxes was manageable. But even though that might sound like a negative, it's a very encouraging sign, because it's like you sitting with a V16 F1, but you're just in second gear because you're too scared to go any faster. But if you have to go faster, you know you've got that reserve under the bonnet, and that's that's my analogy for it. It's great to know that that 20 liters will give you such a dramatic response for the time when you need that recovery. But if you keep your root zone clean, and how do you keep your root zone clean? You follow everything that we spoke about today with biostimulants and timeless applications of OxyTurf.
Thanks, Hilary. That was a question from Sean. We've got another question, or actually, Andrew's just asking to elaborate further on the results you get with 10 liters per hectare as a foliar spray at 300 liters of water applied with nutrients. It's in
okay, this work came to me from a very new customer up in the Midlands. He was doing this, so I then in May this year took on this challenge, and I was doing this with foliar applications at 300 liters a hectare, and I found a very good result. I had a very good result, but I must emphasize that this root zone was completely cleaned up. I'd started with this customer August last year, and from August right the way through to April, we were cleaning up his root zone, and then we started with the 10 liters combined with the foliar feed, and we've kept his root zone completely clear. We have photos to prove it, befores and afters, and he had a couple of greens that sat traditionally very wet. We even kept those profiles clean and free from black layer.
Perfect.
There is another benefit, which unfortunately I'm not allowed to speak about on air.
Okay, well, that will keep for a separate time. We've got another question here from Graham. He's just talking about, well, this is the question. Should you also alter the rates when most bacteria shut down at below 6 degrees Celsius, obviously?
Okay. Again, as I said, I started using the product last year, November. I was very fortunate that one of my customers added it to one of our special biologicals. And we're not going to give a punt for the product name, but I can tell you that it is a proper plant growth promoting rhizobacteria. So it is a proper PGPR. Okay, it's registered as such. It's got accreditation for the amount of coliforms of bacteria in it. It's got 5 species of bacillus, of which one of them is Bacillus liquefaciens. And when added to OxyTurf, this prevented snow mold. And yes, Luke has got his theory about why it works so well. But I will persist this year during cold weather by adding the plant growth promoting rhizobacteria to the OxyTurf.
And the name of it is?
Do you think we should be naming products here?
Yeah, it's absolutely fine. I mean,
you sure? Yeah. Okay. The product of choice is Orobac 100. And you Europeans, you can get it in Europe. Luke will put you on to the manufacturers.
Super. Then we've got another question here regarding, this is from Antonio. Is it possible for OxyTurf to lead to dollar spot development in the first applications?
I don't think so. Dollar spot is quite unique to warm nights, and if you keep your growth active, the plant can resist dollar spot. But again, there are biological fungicides that work exceptionally well at controlling dollar spot, and I can't see a link to the OxyTurf causing dollar spot. What is that? Antonio asked this.
Yes.
Okay, Antonio. What you could be alluding to is the soft tissue growth. You could be alluding to that because if you were to overapply OxyTurf, yes, you could get that soft tissue growth. But generally, if you've got microorganisms in your program, they're pretty good at keeping OxyTurf, keeping dollar spot away.
Yeah, dollar spot's certainly a challenge. We've got another question here with Graham again regarding dew suppression. Does it have any function in that regard, and or could it be added to anything that might produce some dew suppression?
I don't know. I haven't tried, haven't tested. I'll make no comment on that.
Yeah, and I must say, from my side, there hasn't been a particular, feedback related to dew suppression and OxyTurf. There is, no. If you wanted to use it in combination with a product, it's a stimulant, so it stimulates microbial activity, and so it really depends on the mode of action of the solution you're using.
My gut feeling is not to combine the two, but people can try these things, but I wouldn't recommend it. Not that there's a danger, but I don't think you'll be getting good value by combining them.
Okay. Super. Well, that's brought us to the end of the questions. If there's any last question before we wrap up, yeah, please go ahead. In the meantime, yeah, thank you so much, Hilary. This is just another really, really wonderful presentation. So do you want to just give us a last little hint on the heading for next time? So we're doing the next webinar is going to be a combination of the two that we've had, which is chemical as well as the biostimulation in the soil profile. And now we're going to combine the two in the final one to give the mechanism thereof, eh?
That's right. Okay. So I alluded in the beginning to the value of this slide, and it's sitting in your memory bank. This world was perfect. This world, everything functioned, everything was absolutely perfect. Is my cursor still not?
No, so you've got to describe where you are. Just
okay.
read where you are.
So have a look at where the peat has formed, bottom left. Then have a look where the lignite has formed in the center. And then have a look where the coal has formed, bottom right. Above that, you've got humus, which contributes to carbon development. And over on the left, we've got leonidite and lignite derived from peat. Here, nature, all working together. What have we done by introducing playing surfaces in sports pitches and in golf? We've introduced the unnatural. And now what we want to do is, if you go to the center of the picture, you'll see there it talks about natural defense. All the microbes, all the critters, all the organisms in that scenario that you're looking at now had natural defense mechanisms. They talk about systemic acquired resistance, SAR, and they talk about induced systemic resistance, ISR. All of that was taking place naturally. And that's where we want to go with the next webinar. We want to go to harnessing SAR, systemic acquired resistance, and induced systemic resistance. And yes, we touched a little bit on it today. I showed some products that help with both, but we want to take it to a level that you can build your faith on it and rely on it to perform for you. But it's not an overnight fix, as I emphasized earlier. If we want biologicals, if we want nematodes, if we want biological fungicides to work well, we need to prepare the way for them. We need to prepare and do the groundwork. And that's not a pun. We need to get the root zones cleaned up. And that's where today's webinar comes into effect, with the biostimulants and combining them with the OxyTurf. And the OxyTurf just gets that little bit extra out of whatever you're putting it with. So that's the little sound bite for our next webinar.
Brilliant. Thanks, Hilary. Just a last question from Sean. During trials last winter, was there a reduction on Fusarium with OxyTurf? And if so, can you explain how OxyTurf helped in the reduction of Fusarium?
Sean, yes. Yes, I'll say yes to the question, but I can't explain.
Yeah, there's of course we just just keeping it sensitive that there are legal ramifications and regulations. So certainly wouldn't want to promote that it's a fungicide of sorts, or it has a controlling mechanism. However, the improvement, like what Hillary's explaining here, the improvement of the natural defense and the cleaning up of the profile is one of the best defense mechanisms for unwanted fungi like Fusarium. And of course, Fusarium is something that breeds in the thatch area, so a reduction in thatch is, of course, making it difficult for it to spread. I hope that gives you. We can give you more information offline, but that's that would be the last question from Sean. I hope I've answered you enough. And yeah, Hillary, fantastic.
Thank you, guys. Bye, everybody. Look forward to seeing you. We're
still going to announce the date, but we plan to have it just before the end of October. So 4 weeks from now. Thank you very much, everyone, for listening. And thank you again, Hillary. It's been wonderful. Goodbye, everyone.
Ciao.